2022.
There are 5 agendas in today's session. In the morning session, we will have Keynote session 3 and followed by 2 hours parallel session and an hour workshop. Afterward, we will have 75 minutes break, followed by the Keynote session 4.
We are now proceeding to the Keynote Session 3. We will hear the presentations of Professor Trena Wilkerson from the National Council of Teachers of Mathematics USA. And this session will be chaired by the moderator who already joined us here at Ki Hajar Dewantara Hall. Please proceed to the stage, Mr. Wahid Fitri Albar from Semarang State University, Indonesia.
Good morning, Mas Wahid.
Good morning, Mas Yoga.
Okay, please allow me to read your short biography before we start the keynote session. Mr. Wahid Fitri Albar is mathematics lecturer at Semarang State University. He obtained his bachelor degree from Semarang State University in 2015 and his master degree from Universitas Gadjah Mada in 2019. He was an awardee of Indonesia Endowment Fund for Education or LPDP powered by the Ministry of Finance Republik Indonesia. Previously, he was a non-tenure track faculty member of Mathematics Department of UGM, a public relation officer in Mathematics Olympiad Training Institution of Mathematics Department of Semarang State University, and a private teacher. For Mr. Wahid Fitri Albar, the floor is yours.
Thank you, Mas Yoga and Mbak Lily. Okay, thank you for the MC. Well, ladies and gentlemen, it is an honor for me to be here, to be able to moderate this special session. I'm glad, and it is my pleasure. Therefore, when I was offered to moderate the session, I immediately accepted the offer without any hesitation. Well, in this International Symposium of Mathematics Education and Innovation, we will have the first keynote session for today. And actually, we will learn a lot about numeracy from our keynote speaker, Professor Trena Wilkerson. Hello, Professor Wilkerson. Are you here?
I am. It is wonderful to be here. Thank you for the invitation.
Okay. Well, thank you. Before starting the main course, let me read a brief biography of yours. Well, Professor Trena Wilkerson is immediate past president of National Council of Teachers of Mathematics, NCTM, an international mathematics education organization with more than 30,000 members. She served as president of NCTM from April 2020 through October 1st of 2022, so just 5 days ago. She is a professor of mathematics education in the Department of Curriculum and Instruction in the School of Education at Baylor University, where she also served as an interim department chair. She teaches postgraduate and undergraduate mathematics education courses and conducts professional development and research after previously taught high school mathematics for 18 years. Her research interests include mathematics education, teacher education, algebra teacher efficiency, teaching and learning of mathematics, and professional development. Here, she will present a title of Numeracy as a Lens for Understanding and Critiquing Our World. In this session, we will explore the role of numeracy as a key domain of the purpose of mathematics. What is numeracy? And why is it important in mathematics education? What are the challenges in addressing numeracy? And what are effective practices for developing numeracy understanding? How we can support learners in developing numeracy concepts? and skills as they seek to understand and critique their world as productive contributors. Let's engage in discussion through these questions and as we seek to transfer educations by reimagining numeracy. Then, let me proceed to the protocol of this session. Professor Trina Wilkerson will present about 40 minutes and will be followed by 20 minutes of Q&A session. For participants who are joining us from Zoom meeting, you may leave your question via the Q&A chat box with the format name _ keynote speaker _ questions. Well, I will repeat, name _ keynote speaker _ the questions. Okay, and for the participants who are joining offline today, after Professor Wilkerson finishes her presentation, you may immediately raise your hand and I will pick one of you to ask a questions. Okay, without further ado, let's welcome Professor Trina Wilkerson.
Thank you very much. I am delighted to be here. And thank you, Professor Alvar. It's just a delight to be with you. I understand it's morning there and it's night here. So I hope you all have a wonderful day, and it's wonderful to start off with you today. I would like to see if I can share my screen and let's see how that works.
Yeah, let's proceed.
Okay, here we go. Just one moment. What I want you to be able to see is just the PowerPoint slide. So let's see if we can get there. All right. Do you just see the one PowerPoint slide?
Yeah, we see it.
Yes. Okay. Excellent. Not all my notes and things. All right. Perfect. Also, will participants be able to just put responses in the chat box?
Yeah.
Okay.
They are able to put immediately in the chat box.
Excellent. Because I'm going to ask a couple of questions, and people who are there in person, they can respond to you. So thank you again for this opportunity to come together. And you are right. I just finished my presidency just a few days ago. We ended with our national conference and it went beautifully. And I am now past president for just a few days. Well, we are going to look today at numeracy. I understand that's your theme, and we want to think about it today as a way of looking at our world, critiquing it and understanding it. So what does numeracy have to do with that? So we'll talk about what numeracy is, or one perspective, what its role is. We'll look at a little bit of research and theory related to numeracy. We'll also look at some effective teaching practices around it. We'll have some discussions. And then we will be asked to think about, what are we going to do with this? What will be our next steps in whatever role you might be in? And as was shared earlier, the questions we want to consider are listed here. We'll come back to them at the end of the session. What is numeracy and why is it so important? What are some challenges in addressing numeracy? What are effective practices for developing numeracy understanding? And then how can we support learners in developing numeracy concepts and skills? And I would even say that we need to think about, how do we support teachers in their role in supporting learners? So as it's been shared, I've been serving as president of the National Council of Teachers of Mathematics. And NCTM's mission is to really advocate for high quality mathematics teaching and learning for each and every student. And we do this often about thinking about how we support teachers. So as you think about your teachers and other partners you work with in thinking about teaching and learning numeracy, what does it mean to focus on high quality mathematics teaching and learning as it relates to developing numeracy understanding? So in 2018, NCTM released a publication called Catalyzing Change in High School Mathematics, beginning critical conversations around it. And then it followed up in 2020 with a version of this critical conversations piece with middle school, and then one with early childhood and elementary. And if you have heard me speak before, some of you may have heard last year, I did talk about these. So I wanted you to just remind you of them. And we're going to use one piece of it to unpack this around numeracy. So in those 3 documents, there were 4 recommendations that went across all the grade levels, from early childhood to elementary to what we call middle school, and secondary or high school. And they were that we need to think about broadening the purposes of learning mathematics. What does it mean to learn mathematics? The second recommendation had to do with what kinds of structures are in place that help us to teach mathematics equitably to all students. The third recommendation looks at equitable, effective mathematics teaching practices and the instruction. And then the fourth recommendation has some ideas around how do we help students develop really deep mathematical understanding. So in our time together today, we will connect the purposes with developing that deep understanding of mathematics with a little bit of the ideas around teaching strategies. So as we do that, I'm just going to bring up the first recommendation. This is one of my favorites because it makes us think about what the real goal of learning mathematics is, and that we need to think beyond just doing computations or learning formulas. We need the goal to be that students can really see themselves in the mathematics, that they really can engage in the mathematics. And under the purposes of learning mathematics, there are 3 areas. One is to develop a deep mathematical understanding, but becoming really confident and capable learners of mathematics, where students see themselves as thinkers and doers in mathematics. The one on the other side is experience the wonder, joy, and beauty of mathematics, which, by the way, is one of my very favorites. I think one of the most exciting things we can do for students is to get them to see mathematics everywhere in their world and to see how it all connects. And it's just beautiful and it brings joy. And we want students to be wondering about the mathematics. But the third one is the one we want to talk about today, is we want to think about how do we use mathematics, and in particularly numeracy, to help students to understand. And it talks about critiquing, but that just means really understanding their world, and that when they read things, they experience things in their world, that they can look at it through a lens of mathematics and have meaning made of it. So just for a fun exercise, this is where we do a little math. It's always fun to do a little math. So those of you who are in person there, or if you're on line like I am, then I got a little math problem for you. Sometimes it is difficult for students, children, and sometimes even adults to really comprehend the differences in numbers. For example, what does a million mean versus a billion? We could even ask versus a trillion. All right, but we're going to look at a million and a billion. So what does it mean to have a million of something or a billion of something? Or if we read something in, that talks about a million and then later it talks about a billion, do we really comprehend the vast difference between those two? So as an exercise to think about 1 million versus 1 billion, take a moment and calculate how many days are there in a million seconds. If you think about time and you've got 1 million seconds, all right, how many days is that? How many days? So I'll give you a moment to calculate. Any questions about the question? Does everybody understand the task? All right. So pop in the chat box, or those of you in person, maybe share your answer and it can be shared. How many days does a million seconds add up to?
Well, anyone? Okay, they are still calculating here.
That's fine. They can take their time to calculate. Excellent. We've got one in the chat box. Those of you who are calculating, see if you agree or disagree. There we go. Excellent. Can anyone share a little bit about how you did it? How did you come up with the 11.57, approximately 12? It's about 12. How did you get that?
Okay, maybe Mr. Falikul Jana or Miss Falikul Jana want to share her idea, his idea how to get the number, or from Unsut 09.
I calculate first how many seconds in one day, and after that I divide 1 million seconds by divided by 20, 3,600, and I got 11.557. Thank you.
Yes, thank you. Thank you so much for sharing that and sharing your process for doing it. Now, so I rounded mine to 11.6 days, but between 11 and 12 days, so 11.57 is more accurate than my approximation. And so I did 12, which is the same, a very similar approximation. Now, you know what the next question is going to be. If there are 11.57 or approximately 12 days in a million seconds, then how many seconds are there in a billion? What does that do to the number? So how many days is a billion seconds? So I'll give you a moment to do your calculation.
Okay, anyone here? Okay, an offline participant will answer your question.
Excellent.
Okay.
Check. Just multiplicating the result by 1,000.
Okay, why times 1,000?
Because 1,000 times 1 million equals 1 billion.
Right. So it's 1,000 times more, right? Excellent. Now, there are other ways to solve it. There are other ways you could go back to how the other one was done and figure out how many days, etc. You can do that as well. So that's beautiful. So here's the thing that is so interesting. It is so vastly different going from 11.6 or about 12 days to almost 12,000 days. And often when we see these comparisons, as students and adults, we have a better understanding that a billion is not just a few more zeros, it's really significantly more. And just think about if you do a trillion, think about what that does, all right? And so it's really important for us to have students, learners, adults, to really understand the impact of numbers and the differences in numbers. So recently I heard the author of this book speak, and his name is Chip Heath and also Carla Starr. And he wrote a book, or they wrote a book called Making Numbers Count. And he talks a lot about how important it is that numbers are in our world. It's so important. In fact, one of the statements is this, I'll put it up here. It says, getting people to understand numbers in instinctive and accurate terms is important. We need people to understand what those numbers mean, not that they just get an answer, but understand what they mean. The second point that he makes is we need numbers to make sense to us, but we also need those numbers to make sense of our world. And so it's really important that our children, and as they grow up into young people and adults, that they can use numbers to really make sense of their world. There's also one other statement that he makes, or ask a question. He asks, how can we make numbers more understandable and usable? And in his books, he talks about ways to make them more usable. And the example that I gave is just one. It was a very simple one, to think about the difference in a million and a billion, because it really helps us to understand how vastly different those numbers are. But we also read graphs, we read reports, we do calculations, we do things trying to calculate things related to the sun or the moon or around the earth and distances between things. And we just sometimes have a hard time understanding what those numbers really mean. He also has a quote that he says, if you can get people to talk about your numbers, like the answers that you get, then you've won. If they really can understand those numbers, then it's really important. So let's go to this. Let's think about for just a moment, like, what is number sense? So we're going to define, at least where I'm coming from when I think about numeracy. What does it mean for someone to have a sense of numbers? So this is one definition by a researcher named Howden, but notice it was in 1989, and it still applies today. Howden says that identifies number sense as a good intuition about number and their relationships. And for me, the idea of the relationships is really key. It's really key. That's the important part. It develops gradually as a result of, and listen to this, exploring numbers, visualizing them in a variety of contexts, and relating them in ways that are not limited by traditional algorithms. So number sense is much more than just being able to do a calculation, apply an algorithm, and get a number, a numerical answer, but it's really being able to explore relationships in numbers, really being able to see them in different contexts, and then how they're related to one another. NCTM in that same year went on to also add to that defined it as an intuition, like you could just know this about numbers that is drawn from all varied meanings of numbers. So you need to understand numbers in a variety of different ways, not just as the number that's written. There are many, many ways. So we're going to talk about that a little bit. So one of the key important areas is related to number sense. The dimensions of number sense and operations sense really foster this idea of flexibility. We need to be able to work flexibly with numbers and be confident in our numerical reasoning. These are really important when we're thinking about critical topics in mathematics for our early children. One of those really key ones is a word called subitizing. And I don't know, do y'all use that word subitizing? I don't know if you can put in the chat box. Does anybody know what subitizing means? That S-U-B-I-T-I-Z-I-N-G. What does that mean? Anybody have a thought? And Professor, can you tell me if that is a word that is used in mathematics for your students? Oh, there we go. The ability to know the number of something by simply looking at it. I love it. That's it. Is it Rusamita? Is that correct or not?
The ability to know the numbers.
Yeah, it is just the ability to know that that is what the number is without having to count. And we see this sometimes in patterns. We see this sometimes in games we play, that you can look at it and you immediately know how many it is. And it is a key aspect of numeracy. And another thing that's really important about this, if I can share this, it is really important that students continuously interact with numbers all the way from early childhood, even before school starts, or before regular schooling. Doug Clements does quite a bit of research in the elementary and early childhood grades. And he shared this. He says he distinguishes between two types of subitizing. One is perceptual and the other is conceptual. The perceptual subitizing is seeing and naming the total quantity of objects in a set without counting, exactly what was shared in the chat box. So thank you. So for example, a child may roll a dice, a number die, and just know how many dots are on it, like there are 4, or there are 6, or there are 2. And they know that without counting the little pips in it. Children and adults can usually perceive sets of 2 to 5 objects very easily. When it gets larger than that, sometimes they have trouble. But the second aspect that Doug Clements talks about is the perceptual supervising. And he says this is aided by familiarity with patterned arrangements, such as those found on dice and dominoes or other forms of finger patterns that you might do. Conceptual supervising is seeing smaller subgroups inside a larger set of objects. So you might have a larger set of objects like 20, but because they're sectioned off or grouped in, you might see 5, 5, and 5, and 5, right? Or something like that. And so you can immediately know quickly how many are there by conceptualizing or grouping them in subgroups that you automatically know that's 5, and that's 5, and that's 5, and count them that way to do the total. So that's sort of, usually we just think of it as just looking at it, but it can be more complex. Even larger groups can be broken down into smaller groups, and that is also an aspect of subitizing. So thank you so much. I wanted to share a little bit more about what research says about us thinking about research and in numeracy and what that means. So one of the things that research says, this is a compilation of research done by Jordan, Kaplan, Romanini, Lusaniak, and also Lynch and Kim. And so it simplifies or synthesizes to, if students do not build a strong foundation of mathematical knowledge in early grades, and this is the numeracy part that they do in early grades, the cumulative nature of mathematics can hinder them as they grow older. And you let that sink in. What children do in those very early years of school, and even before they go to school, that strong foundation is critical, because if they don't build that strong foundation and it continues to grow, then it's going to hinder them in the future or keep them from being able to do other things in mathematics. Claessens and Engel also say, and this is what research has shown, that early mathematical knowledge, this early numeracy kind of information, is a predictor of future mathematical achievement. Now think about that. If students can develop a really strong sense of numeracy early on in their early grades, it is actually a predictor of how well they will achieve in mathematics later. So having this strong sense of number when starting in school is a predictor of how they will do in advanced mathematics, how they will do as they grow and go further in mathematics. Alfenia Flores said that reframing the problem in terms of opportunity gaps is what needs more attention. Because what happens is, it's not that students have an achievement gap, it's that they've not had an opportunity to learn mathematics. Maybe they've not had the resources. And I don't know about in your country, but in our country here in the US, there are many areas of where students live in poverty. They live in very areas that are lacking resources. Some schools lack resources. Now, there are other schools that have lots of resources, but there are some that don't. And those children that don't have access to the resources are really at a disadvantage. And so it is really important that critical foundation start early on. One last comment from Carter and Wellner. They say that the achievement gaps that we talk about, the difference in student mathematical understanding, again, is from opportunities that they've not had. So we need to build those opportunities to help children achieve. Now, notice this was in 2013. Now, you and I know that we've been through COVID. And in 2013, there were opportunity gaps. There were places students didn't understand things and didn't have opportunities. But we also know that during COVID, that became much more pronounced. There were many more children that lacked the opportunity to learn for a variety of reasons. So just to continue, NCTM also talks about that a hallmark of both number sense and operation sense is that flexibility I mentioned earlier. And students need to be able to work flexibly with numbers in different situations. And this only develops when they have learning environments that really value multiple strategies and diverse ways of solving a problem. And this is really critical. This is talked about in the NCTM 2020 document of catalyzing change, as well as the principles and standards. So they need to be able to flexibly work with numbers, and that comes out in them being able to apply different strategies and looking at different solution paths. So just to continue, NCTM also shares in catalyzing change that number sense and operation sense must be intentionally developed and nurtured. I love those two phrases, intentionally developed and nurtured in children. So we, as teachers, we need to work to intentionally think about how to develop number sense with students. And we need to nurture that or help that grow in children. And it needs to be woven into the culture of the math classroom in everything they do. And it's so that they can see their world. This helps them see their world through a numerical type lens, a mathematical lens. So as we said, just to recap, let's see if I can get it to move forward. Here it goes. Children need to be able to work flexibly and confidently. 2, compose and decompose numbers. To represent numbers with concrete objects or visual diagrams. To know how numbers relate to other numbers. To use what we call benchmark numbers, sometimes friendly type numbers, to approximate the relative magnitude or size of numbers. And then the fourth one is to recognize the absolute magnitude or size of numbers in real world situations, often using personal reference. And so this is like thinking about, when you think about really young children, you might have 2 objects laying down, 2 sticks, for example, and you're asking students, you know, is one longer than the other? Are they the same? Now, they're not actually using a number, but they're able to actually compare just because they can see the length. Then later, they get introduced to numbers and measurement, and they're able to use numbers to understand that magnitude, that size of that number. And then they're able to use things in their own world when they can see things like this is larger than this, or there are more of these, or less than these, or there are about 12 of these, or there a lot of these, like 100, whatever that happens to be. But these are some of the things that are very important in students to develop this number sense. So I want to share something from Markovitz and Sauter, who've done a lot of research with children in number sense. And they share that children's number sense and operation sense can become stronger or weaker over time. Now, how does that happen? It says as a direct result of their mathematical learning experiences. In other words, it matters what we do in our classrooms and at home when we're working with our children. It matters. The more we do that's intentional, that is instructional, then we can support their development of number sense. If we overemphasize just memorizing, okay, then they're missing the real fundamental understanding of mathematics. And to be honest, they're missing some of the enjoyment of learning mathematics, because if they're just memorizing, and not that we don't memorize some things, but if students are only memorizing, then they're not making sense of it so that they see the connections in their world. So we really need to foster or help grow that developing number sense. And I keep talking about early childhood, but understand this continues in upper grades in elementary, working with fractions and decimals and percents. It continues on in working with rational numbers, irrational numbers, and imaginary numbers, complex numbers. So it continues throughout their lifelong learning. And it's really important for students to develop this foundation over time. Baruti shares also, and this is shared in NCTM as well, that number sense approaches trust that children are intrinsically motivated to make sense of their world. And so they look for those regularities, they look for those patterns. They walk around in their world seeing mathematics and are able to make sense of it. And it brings them joy and excitement in learning mathematics. So I'm going to stop a moment and I'm going to let you put in the chat box or share in, if you're in person there at the site, and talk with one another. If you have others you can talk with, what are some of the key ideas that you think are important in your curriculum that relate to numeracy? What is it that's really important? What are those important ideas that are related to numbers? I may have mentioned some earlier, so you can include those. But what are the key ideas when you look at your curriculum, you look at what you're teaching, what's important related to numbers? And if you'll put those in the chat box or share them on site, that would be great.
Okay. Anyone? Anyone in the Zoom wanna answer in the chat box? Yeah.
Excellent. Flexibility, thank you. Contextualization of curriculum, very important. That's what helps them make sense of their world. I love that.
Anyway, more ideas from offline participants?
What are some important ideas around numbers or numeration or numeracy?
Okay.
There you go.
One is going
Related
to answer.
numbers.
Yeah.
Yes. Oh, yes.
Mention your name first. Maybe.
Number one is pattern and number two is relation. Thank you.
Yes.
Yeah, pattern and
Both
relation.
very, very important. Patterns and relationships. I love that. That's great. Okay. And Rita mentioned relating numbers to your real life. And again, that's where they see it in their world. All right. Excellent. Thank you. So I'm going to share a few more, many of which you've already mentioned, but I'll share a few on this slide. It's that relationships that you just mentioned. That's the first bullet. The second one is understanding the idea of what a unit is so that you can compare quantities. For example, someone might think that 5 is always bigger than 4. Now, the number itself in counting objects, 5 specific objects that are the same objects of another one and there's only 4, then 5 is more than 4. But 5 centimeters and 4 meters are very different, okay? Or vice versa. I could have 5 centimeters and it is much less than 4 meters. So in that case, you have to know what the unit is. That's really important to compare quantities. Counting, we know, is a fundamental in early grades. But notice the word in front of it. It's meaningful counting, to really understand what it means. And you know that children develop this. They, some of the children really early on can count objects. They'll go 1, 2, 3, 4, 5. But then sometimes I'll ask them, I'll say, count them for me, and they'll go 1, 2, 3, 4, 5. And I'll stop and I'll say, that's great. I said, now, can you tell me how many objects there are? And they'll go, I don't know. I said, okay, well, count them again. 1, 2, 3, 4, 5. And then I'll ask them, well, how many objects are there? And some of them will still say they don't know. And it's because they've not made the connection between the counting and the last number being the total number of objects. Now, that's a very basic example, but you can bring that all the way up into imaginary and complex numbers. Just because a student can write about a complex number does not mean they understand what it means, and especially in context. And that brings up the next bullet about numbers are actually abstract concepts. They are a symbol that we've given to some particular relationship. And then most of us use base 10. Now, we know there are other bases that you can use, and base 2 is a very popular one that we use related to computers. But we often use base 10 as an efficient way, not the only way to write numbers, but it is one way that we can do that. All right. I want to take just a moment just to go over a couple of more things, just to share with you that there are some pre-numeric kinds of ideas that are important. We talked about comparisons, the physical objects and what that means in counting, the relationships, and then conservation of numbers is the last one. And you will be shared with I'll share these slides with you later. But there are some just pre-numeric kinds of fundamental things. But then that leads to these key things, that concept of that unit, the counting ideas, and really building ideas about place value. So just sharing that with you from what we talked about earlier. All right, so a little bit more, I just want to share with you about fluency and what that means. It is related to number sense, so computational fluency is important, but it becomes more effective when there's a strong sense of number. And if we rush to get fluent in just computation, then sometimes that really causes a lot of anxiety for students if they don't understand what it means. So it's really important to develop that understanding. Now, you may have heard me talk last year about effective math teaching practices, and there are 8 of them that we talk about in Principles to Action that's over here. Establishing your goals, looking at reasoning and problem solving, multiple representations, discourse or discussions you have in class, questioning is very important, supporting students who may be struggling but doing it in a productive way. And I'm going to come back to number 7. The last one is about using student thinking. But number 7 is the one I want us to look at for a moment. Is this because we're talking about numeracy? How do you build procedural fluency from conceptual understanding? That's a really key aspect. And the statement says that effective teaching of mathematics builds fluency with procedures, but on a foundation of conceptual understanding, so that students over time become skillful in using those procedures flexibly so they can solve contextual and mathematical problems. So very important for us to think about. So procedures are important, but they need to be built on conceptual understanding. The two go together. In Principles to Action, they talk about 4 sort of steps or directions for building that fluency. Initially, students explore things around numeracy. Then they begin to discuss things about number concepts. Then they have some informal reasoning about number concepts. And then they develop those generalities so that they come up with algorithms and patterns that they see. And we won't have time, I think, to go through this in detail, but I just wanted you to share that when you get the PowerPoint, the slides, to notice that when you're building this procedural fluency from conceptual understanding around numbers, it's important to look at what teachers are doing, but also what students are doing. So for example, teachers here are providing students with opportunities to use their own reasoning strategies and methods for solving problems. Students then making sure that they understand and can explain the mathematical basis for the procedures that they are using. So in the number sense, the numeracy sense, we need to give opportunities as teachers for students to use a variety of strategies, but then students need to be able to explain what they're doing. So those are important for us to think about. So always think about what's the teacher doing, but what is the student doing? So it's not the teacher just doing everything for them. I'll give you another example. Visual models. Teachers should use visual models to support students' understanding, right? But students use those models and then move to being able to use those procedures that they learn in appropriate and efficient ways. So there's a combination. You need both. You need practice, but you also need to develop that conceptual understanding so that you can use it in new situations. So I want to share a research project that a colleague of mine does. It is called Math for Early. It's supposed to be learners. I'm sorry, I left the letter R out. Sorry about that. Math for Early Learners Academy is an early childhood intervention for children who are coming from areas that have lacked opportunities to learn. And so these are the children. This is one group. She's been doing it about 6 or 7 years. She's been studying it, not only doing activities and things with them. They're 4 to 6 years old. They are doing really hands-on learning experiences around early number sense. That's what they're trying to develop. It's a 4-week experience, and they come in and they do have a sort of an assessment to see where they are, and then they do that assessment again at the end of the 4 weeks. But I'll also share with you that they do that assessment again later on in the school year because they want to know, does it last? Does it last? They see great improvement over that 4 weeks, but the question is, does it stay with the students? And so this lets you know that the Math for Early Learners Academy, which we call it MELA, that is a very diverse population. We have, there were 2 different schools in this study, and you can see that at one of the schools, almost half are from the Black population, another half Hispanic, very few of white students in this particular one. So there's a lot of diversity in these students, but this is more telling here. Many of them are disadvantaged. They come from areas that have fewer resources. So they have some particular challenges. So they come to this academy, they do all these wonderful math activities. And the question is, well, what happens? What does it mean? Well, what they found out is that they did show growth in their understanding from the time that they started the academy, the first few weeks, all right, but it extended on into their first year of school, and it still was strong. And they grew in a number of areas related to number sense, and that growth continued over the next year. So that was really wonderful. It wasn't just the immediate year they came out of, but even the next year, because remember earlier we talked about how important that foundation was. And this, I think, is the most telling thing. Obviously, all the children at the school did not get to come to this. But what happened was they also assessed some of the children that were not in the project, the intervention. And what they found is they demonstrated decreased gaps when compared to their peers, even after 1 year. So the students who were in the academy had a much stronger foundation, and it continued to grow, as opposed to those students who were not and didn't have that same experience. Now, because of that, they also are working with the teachers so that the teachers can use these strategies that they're using in their classrooms, so that all children can benefit from these strategies. So it is about the students. It's so that they develop a positive math identity, they develop a sense of mathematical agency and a mathematical authority in the classroom. We want them to be thinkers and doers of mathematics. So we return to our questions. I hope you have some ideas around what numeracy is, why it's important, that there are some challenges with it. There's some effective practices we can use. And then you're beginning to think about in your own how you can help develop these in your students. So I'm going to stop now first and ask if there are any questions. And then we're going to come back to see what your next steps might be. So let's see if there are any questions. Oh, and Alvin, I love what you wrote. Important ideas are differentiated instruction with localization and indigenization. So very important. We need to connect it to their culture, to their community, to who they are, so they can see math in their world. That's wonderful. Thank you.
Prof. Wilkerson, we have one question here from a participant who is joining offline. Yeah, you may ask your question directly.
Thank you. Good morning, Professor Trena Wilkerson. In one of your journal article published by GRME, written that reading literacy has enjoyed the spotlight in the last few decades, and deservedly so. I agree with you with that statement. And I thought in Indonesia, the number of reading literacy activists is more than the number of mathematical literacy activists. Even the term of literacy refers to reading literacy only, not including mathematical literacy, ICT literacy, and other literacy. How to deal with this fact that mathematical literacy is not popular? And maybe a little question, what is the difference between numeracy and mathematical literacy? Thank you.
Okay, so yeah. Would you like to answer it directly?
Yes, yes, that's a very powerful question. That same situation of reading literacy being seen as more important than math literacy and more acceptable than math literacy is true here in many places in the United States as well. I think part of it stems from, we do want all children to be able to read. We know how powerful that is. But what we've got to continue to do in our math world is to get everyone to understand that math literacy is just as important. You think about it. The future of our world is in the hands of the children that we're teaching now. If they don't develop really strong mathematical understandings, then they're not going to be able to lead us in our world. Math is extremely important. It is the future of what our students need as far as literacy. And in fact, I didn't even talk about statistical literacy in relation to numeracy. That's another whole area to talk about it. And if you think about it, our students need mathematical and statistical literacy just to be able to understand what's going on in their world. If they're going to try to make a difference in some issue that they see in their world, some challenge that they're coming up with, so developing new, inventing new things, they have got to have mathematical and statistical literacy. So I think that all of us in mathematics have to continue to remind people and push the agenda of how important mathematical literacy is. It's also important that you pointed out that there are different kinds of literacies. Reading literacy is just one of them, but there's also media literacy, there's mathematical literacy, there's computer literacy, there's technology literacy. I mean, there are many aspects of literacy. And the more we help all of our students to develop their multiple literacies, the more effective they're going to be in the future and the more opportunities they will have in the future, which is another reason why mathematical literacy is so important. If students don't develop that mathematical literacy, it closes opportunities for them in the future. Okay, so that's really, really important. And I think those are messages that we need to continuously push and show people why math literacy is so important. That was the first question. Second one, you ask about numeric literacy and mathematical literacy. And I think in my mind, and others may have other thoughts, I'd love to hear them. I see numeric literacy or numeracy as a literacy that's within the broader mathematical literacy. Mathematical literacy encompasses many areas like geometric literacy, visualization. That is also very important. Functions. Granted, there are numbers in functions, but just having functional literacy is very important, being able to understand functions and relationships. So there are many aspects of, and statistical literacy I already mentioned. So I see numeracy or numerical literacy as a part of mathematical literacy. Now, I would love to hear from you. What do you think about those two questions?
Yeah, thank you for the explanation. I think from the previous speaker, they stated that the numeracy and mathematics is different. So I want to know what is your opinion between the numeracy and mathematical literacy, because I have, some confusion. I'm confused about the difference between the numeracy and mathematical literacy and any other literacy.
I'm sorry I didn't get to hear the earlier speaker, and I can certainly see how they see them as separate literacies. I think they're connected. I think you can have, because I think there are other aspects of mathematical literacy. Numeracy and understanding numbers is a piece of it, but there's much more to mathematical literacy than just numeracy. And so I certainly see that for sure. So I'm glad you're thinking about it and digging into it. You will need to study that and decide for yourself how you see them as related or not. So that's very powerful. I love that.
Thank you, Professor.
Yeah. So I did see a question. Do you want me to answer the questions that I see in the chat box?
Actually, there are two questions from the chat box, but I will just one for now.
Okay.
The first one is from Wahid Yunianto. How to support primary teachers with lack of confidence of mathematical skills to support students' number sense?
And that is a great question. We have that same concern here in the schools that I work with. Our primary teachers, our early childhood teachers, many of them are not confident in mathematics. We see this in the project that my colleague does with the students in the Mathematics for Early Learners project, that some of the teachers do not have confidence in doing the mathematics. They don't have a strong sense of number sense, and therefore it impacts their teaching. So therefore they often will just teach children to memorize something because they don't understand it themselves. So how do you work with that and help build their confidence? One of the ways is through professional development with teachers, bringing them in to do the mathematics, putting them in a safe environment, a place where they can ask questions to really try to understand the mathematics. They need to experience mathematics in the way that we are thinking about how we should teach mathematics. Many of them don't have that background, and they need to experience developing their own number sense, their own understanding of numeracy, and then use those strategies, using materials, and then take those back into their classrooms. They have to become open to children sharing their thinking. That's also scary sometimes for teachers, because sometimes they're afraid the students will explain something and they won't understand what the child is talking about because they don't understand the mathematics. So we need to continuously support them in professional development, working with the teachers one-on-one, supporting them in their teaching, helping them to plan. I think we also need to work better in our pre-service teacher training programs. We need to help them to experience the mathematics in the way that we are wanting them to have their children experience the mathematics. A great question.
Well, it is a comprehensive answer from Professor Trina Wilkerson. Excuse me, Professor, you said that you will stop by the questions and answer, and then you will continue to explain more.
Just one thing. Here it is.
Yeah.
So I would love for you to share, either in the person audience or in the chat box, for you, based on what you've experienced so far, not just in my session, but the others that you've already had, at this point, what's going to be your next step, your next action? What are you going to do related to developing numeracy to understand and critique our world? What is your next step going to be? In whatever role you're in, what's the next thing you're going to do? So I'll give you a moment to think, and then I would love for you to share, what's your next step going to be?
Oh, okay. It is a reflection questions, and anyone wanna share your next text and action in developing numeracy to understand and critique our world.
So in the chat box, Alvin's talking about changing the mindset and teaching paradigm of teachers and inculcating numeracy as part of teaching mathematics. And this is really good, because you want to develop that culture of teaching numeracy, of thinking about numbers and thinking about different teaching strategies. So I love that. It's often changing the mindset from memorization to really understanding and developing flexibility in using numbers. So I think that's very important. So thank you for sharing that. What about one more? What are you going to do? Yes, I agree. Yes, Terry.
One more who want to share their ideas from the offline participants? Or from the, okay, we have one here.
All right.
First of all, I try to learn more about numeracy, and then I invite my friends, my colleague to learn together about numeracy, and we try to make professional learning society, or whatever the term, and then we try to influence the principal of our school. Maybe like that, Professor. Thank you.
Thank you. That's two very important areas. One is to continue your own learning, reading about it, experiencing it, studying it, then bringing in your colleagues to share this thinking together and to learn together, your professional learning community. But then I love also your next step is being able to then take that to your principal, to the administration, to say, these are some things that we need to do, and maybe these are some resources we need or support that we need. So I think that's really important. So I really appreciate you sharing that. Yes, and develop, oh, that's another really good one. is to be more confident in your own mathematics. And we have to work at that. There's certain areas that I'm very confident in, and then others that I have to study a lot more and learn more. Training programs for teachers, that's a huge one as well. Thank you for sharing that. We have much work to do in that. And then as a math teacher, assisting your learners and the teachers. I love this, in designing their thinking ability in numeracy and making meaningful connections. And listen, look at that, in their day-to-day activities. So in other words, in their world. And then embracing the changes in curriculum and teaching practices that promote numeracy. And then another is the professional networks of math teachers. And you've got groups here. And one of the good things, I guess, that happened as a result of COVID is it's really connected us through technology in ways that we had not experienced before. So you can create your own learning communities, not only within your school, but across schools as well. So that's wonderful. Well, I thank you so much for the opportunity to spend time with you. We're on a journey in teaching and learning mathematics, and in particular numeracy. And sometimes it can be overwhelming, but our journeys that we take begin with small steps, and then we can do that together. Thank you very much.
That's such an amazing presentation. I will have got a lot of knowledge from that. And before we close our session today, let me give you some remarks that maybe don't exactly represent her speech, but it will be a remark, some of them. The first, okay, we have mathematical numerology is very, very important, and it has some view as a perspectives, and then the strong foundation of number set. Well, thank you. Okay, and number sense has to be intentionally developed and nurtured from the early childhood, though it can be stronger or weaker through times based on the mathematical learning experiences. And one of the remarks that Professor Wilkerson stated that maybe one of the factors that it can be weaker is just when they learn mathematics, they learn numbers just from memorizing. So it can be weaker. And then all in all, since of pandemic, due to pandemic, we have to glad that now we can familiar with technologies. So you can create your web, you can create your communities not truly from offline that we did before the pandemic. Now we can do the both, creating them by online and offline. So we can enhance the mathematical numeracy and mathematical literacy to be popular again. So thank you, Professor Wilkerson, and give applause to Professor Wilkerson. And this is for our session. Thank you, Professor Wilkerson, and I will give it back to the MC.
Mr. Wahid Fitri Akbar for chairing the Keynote Session 3. Thank you very much, Philip. Please give a round of applause. And also thank you for Professor Trina Wilkerson for a very interesting and insightful presentations. For Mr. Wahid, please remain on the stage. We are now presenting the online certificate of appreciation for Professor Trina Wilkerson. Thank you, Professor Wilkerson, for the presentation entitled Numeracy as a Lens for Understanding and Critiquing Our World.
That's beautiful. Thank you so much.
Thank you very much.
Next, we would like to invite the Symposium Chairman, Mr. Suhananto, to hand over the certificate and token appreciation to our moderator, Mr. Wahid Fitri Akbar.
Yes, thank you very much, Mr. Suhananto. And thank you, Professor Trena Wilkerson, Mr. Wahid Fitri Alban, and Mr. Suhananto. You may return to your seat. Thank you.
Ladies and gentlemen, this is the end of the third keynote session, and we will proceed to the parallel session. For offline participants, we cordially invite you to the parallel room, and those who join online, we kindly invite you to the parallel virtual room using the Zoom ID and password as shared in the program book. And if you need further assistance, please do not hesitate to contact the committee. Thank you.
Distinguished participants, allow me to inform you for the rest of our schedules today. We will have 2 hours of the parallel session and 1 hour of the workshop. Then we will have a 75 minutes break, and we will see you again in this room after the break at 1 p.m. GMT +7. Please be mindful of the time as we will continue the session on time. Thank you, and we wish you a fruitful session and workshop.
Vicky.
Ya, sequential order jadi hari ini kok kita bisa matching hari ini